Hello, let's continue with the next subtopic, which is stereoisomers. So in our syllabus, we only focus on enantiomers and also cis-trans isomer. So in this video, we will focus on cis-trans isomer. So cis-trans isomer need to fulfill two requirements. The first one is consists of carbon-carbon double bond or carbon-carbon single bond, but must be in the cyclic compound. Why? Because if they fulfill this requirement, they will show restricted rotation. Next, each carbon here must attach to two different groups. Okay, now let's look at here the example. First, contain carbon-carbon double bond. This carbon have two groups, hydrogen and CH3. Both these groups are different. And then another carbon also have hydrogen and CH3, which also different. In this case, this compound can show cis-trans isomer. So how to differentiate cis-trans isomer? If the similar compound is next to each other, the tepi-CC, so we consider dia adalah cis. But if the atoms of is bertentangan, so I remember it as trans. Another example over here is the cyclic. So this carbon already have two bonds bonded to carbon. So here is one group, there is another one group. Both of them are different. This one also CH3, H and the other one CH3, they are different. So they can show cis-trans isomer. So again, you will notice if the hydrogen next to each other like this, we call it cis. If the hydrogen, one is up, one is at the bottom here, so we call it trans isomers. Next one, we are going to check with the exercise whether it is can show cis-trans isomer or no. Okay, for example, we can see the double bond. So this is the carbon, these two are the carbon bonded at the carbon-carbon double bond. Okay, so here the one group, two group, different. Here got two group but similar. Therefore, compound 1 cannot show cis-trans isomer. Second compound, we have carbon-carbon double bond. And then carbon at the left-hand side consists two groups, C6H5 and hydrogen. These two groups are different. And then the carbon at the right-hand side has hydrogen and bromine, also different. So number 2, compound 2, they can show cis-trans isomer. Let's proceed to the third one. These two are the carbon bonded with double bond and also consist two groups, chlorine and hydrogen, different. And then another one, hydrogen and bromine, also different. So compound 3 also can show cis-trans isomers. Compound 4, we have the carbon and the carbon with two bonds. One is hydrogen, another one is OH. This carbon also one bond bonded to H and another bond bonded to OH. Both are different, so compound 5 can show cis-trans isomer. Let's check the last compound, compound 5. This is the carbon, and we consider this is the restricted carbon as well. So this carbon consists 2 groups, but both of them are CH3, they are same. Here also have 2 bonds, which are bonded to hydrogen. 2 groups, both are same. If we look at this carbon, also still have another 2 groups, both of them also hydrogen, which are same. So this compound cannot show cis-trans isomers.